This is the solution to x0 to 1. Okay, so then, this first one is almost correct. The problem is that they didn't write the plus c, so then they forgot the plus c. Now, from the student's point of view, it kind of seems like they forgot the plus c, but from the instructor's point of view, the problem is that maybe the student doesn't know that the antiderivative procedure is not exact. It doesn't exactly undo the antiderivative. So the plus c from the instructor's point of view is quite important. So here, the problem is that they used the variable x. Should have used the variable t, so that the correct answer would have been, going this way, something like 6 multiplied by t to exponent 6 over 6, and then plus a constant, and the 6's cancel, so this would be t to 6 plus a constant. So from the student's point of view, this is sometimes kind of a trivial matter, but from the instructor's point of view, it's not trivial at all, because in just a few weeks' time, we're going to be using multiple symbols, x's and y's, x's and t's, and we're going to be computing antiderivatives, and we need to be sure that we're using the right symbol. All right. So this happens. They should have used a t, and then in some sense, the reason this might have happened is that some students think x is special, but it isn't. The specialness of the symbol in the exercise, or at least for an antiderivative, is entirely to do with what differential is this. All right. So this is not even close to correct. There's two antiderivative rules that look superficially similar. So one of them is the power rule. The power rule is the antiderivative of x to exponent n dx is x to n plus 1 over n plus 1 and then plus a constant. This works for n not -1 and n a constant. Then we have the exponential rule. The exponential rule is like this. So the antiderivative of a to x dx is a to x divided by the logarithm of a plus a constant, and this is for a positive not equal to 1 constant. So they look kind of similar, but in the end, the power rule is for variable to constant exponent, and the exponential rule is for constant to variable exponent. So the mistake here is that the variable is x, and a student used the power rule when they needed to use the exponential rule. So the correct answer would be 7 to x divided by log 7, log 7. plus a constant, and in a sense, the reasonable guess of what went wrong is that student actually accidentally used this one and needed to use this one. For this one, it's pretty simple, and that is that the student almost got it right, but actually you need to use the correct rule, and that is with absolute value. So forgot the absolute value. For this one, again, there's two rules. The power rule, which is written right there, and then there's the logarithm rule. The log rule, so notice that the power rule doesn't work when the exponent is -1. So in the specific case that the exponent is -1, and remember that a negative exponent can be written as a positive exponent if you move that factor to the denominator. So this is 1 over x dx, like so. So the logarithm rule tells you what to do with such things. And the answer is that this is the logarithm of the absolute value of x plus a constant. And this 1 over thing is what causes the false match here. So notice that this x, it's 1 over thing and then d thing, and these are the same. What that is, that's an x and that's an x. The problem here is that z to 5 and z are not the same. And therefore, you can't use the log rule. The way to fix it is to take this antiderivative and algebraically manipulate it just slightly, and you could say that this is 3 multiplied by z to exponent -5 dz, writing this with a negative exponent, and then doing that it's more clear that you need to use the power rule. So the answer is 3 multiplied by z to -4 divided by -4 plus a constant.